ustedes digan, o la puedo poner después, como ustedes quieran.
Me da igual a mí.
Si quieren, hago así.
Sí, pon la primera y pon un slideshow y ya está.
Sí, que no te dejen.
Perfecto.
So, Joan, should we start it?
Yeah, let's start.
Okay, so welcome to the fourth Presence XR webinar. We are really delighted to have you with us. Shortly, Dr. Joan Llovera will introduce our guest speaker, Dr. Veronica Orvalho. We are recording this session for our website, but your video and data are private by default. However, if you use the raise hand feature to speak, your audio and camera will be captured. You are welcome to submit your questions through the Q&A box at any time during the presentation, or alternatively, you may raise your hand at the end of the session to ask your questions directly. Dr. Llovera, the floor is yours.
Hi, thanks for joining the fourth session of the seminars of the Presence XR project. Today we have with us Veronica Orvalho. She's a professor at University of Porto, where she teaches computer graphics. She's also the founder and CEO of Didimo, which is a deep tech company transforming how digital characters are created. She has pioneered the technology that helps turn this traditional manual process of creating a character into basically what is programmable infrastructure. She's also the Portuguese ambassador for the European Innovation Council and has long been involved with SIGGRAPH, both as an author and as a reviewer. And most recently, as the SIGGRAPH submissions chairs in both 2025 and 2026. She also has given talks in many venues in SIGGRAPH, TEDx, GamesBet Summit, and received several international recognitions, for example, the IBM Scientific Award or the EU Women Innovators recognition. Today, she will talk about how we represent ourselves in shared virtual environments. Veronica?
Thank you, Joan, for the lovely introduction. And I'm really delighted to explain and walk you through pretty much as much as I can all the learnings that I had in the past, I don't know, 20 years, encapsulated in five key insights. And then I will walk you through a few of the projects that we have been involved and show you a glimpse of what the future can look like to hopefully inspire your imagination on what new innovations you can do in terms of creating digital characters for the virtual world. So before I get started, this is a little bit about myself. I am a professor at Porto University, so I've been teaching there for more than 17 years. As Joan said, I created Didimo as a spin-off from Porto University. So much of the outcomes that you'll see today were actually at a certain point in time, either a master thesis, a PhD thesis, some crazy idea that we had at the lab that we end up evolving and creating algorithms and novel technology. And then on the side, I am passionate about education. So every time I can, I sponsor kids to go to university. We build classrooms in Africa and schools in Argentina. So every time I can, I in particular like to champion girls to get into science and technology. So that being said, this is a snapshot of my career up until now. So as you can see, there's never a straight path to get to where we are today. So hopefully this also inspires you to always be motivated and understand that sometimes what you will be doing 20 years later can start uh, with a completely different goal. Like if you, I ask myself, and the 18-year-old, I always want to be an executive at IBM. So that was my first job. I got my first job at IBM when I was 18 and worked there all through college. And then life took me to Barcelona, where I did my PhD in computer graphics with where I met Joa and Mels later, and a bunch of people that you will be meeting in the next sessions. And then the PhD took me to work with companies like EA that validated my PhD thesis. And I'm sharing all this because hopefully there are many PhD students that are going to see this. So it was very, very critical that when I was doing my PhD, I contacted many companies that you see here on this slide, and I asked them to evaluate and help me through my research. And then at the end, they end up using the algorithms I've developed. So uh, that being said, the first really breakthrough that we did was how can we go from a 2D image to creating 3D characters. So in terms of automating character generation, you will hear me repeat this several times throughout the presentation. There's one key thing which I learned when I was doing my PhD through an artist, and she clearly stated that when creating content, and 3D content in particular, she always wanted to be able to define the specifications of how the assets are going to look, how the art style, how the geometry, how the rig, how the animation should look like. So that kept me on my mind, and um, I kept on thinking, okay, so we cannot make a system that is absolutely that we cannot have the artist actually use a software that is rigid. We needed to create algorithms that are generic enough in order to be able to adapt to the artist needs. And you're probably all thinking, okay, where Gen AI fits in all this. So I'm going to eliminate that question out of the box now. So everything I'm going to be explaining has no Gen AI involved or LLMs. Okay, I'll touch on LLMs at the end. So the first breakthrough was, okay, how can I grab a photo and get the 3D character? Is likeness an issue? Is it difficult to achieve? So when we started, 15 years ago, it was really, really difficult to create photorealistic likeness. So now likeness is no longer a problem. We nailed it down, and you can see how we've done it in Mariana's SIGGRAPH paper. Many others have worked on likeness, so there's so many different ways on how to solve the problem. So now that likeness is actually solved, how can we actually go above and beyond? And that's what we work through. How can I grab concept art and convert it in a 3D model? Because at the end of the day, what we want to do is to make sure that things look beautifully. And if someone has questions, we can touch on the uncanny valley at the questions. I'm not going to talk about the uncanny valley here. So the real problem was, okay, the industry is absolutely stuck in the sense that creating digital characters takes a long, long time. So it takes a long, long time to create one character. How long will it take to create many characters? And when I say creating characters, it's a character that is ready for production. That's very important, because today you can still find algorithms that can do reconstruction based on concept art or images or even prompts, but the asset that comes out is far from being ready to be ingested into a production pipeline. So what I mean by that is, whatever comes out, can I put it immediately in an animation scene for a film? Can I put it immediately in a game? So that is very complex, and that's what we have solved, and that's what we have been working on. So we pretty much, in order to do that, we had to nail down how we can do automatic model reconstruction with clean geometry. How can we do texturing and do UV setup correctly? How can we set up a rig that allows for any type of animation and it will not break if I change the geometry of the body and the variations of the body size? How can we transfer animations? Animations is really tricky, so we've done a good job, but there are other companies that actually do a better job in animation retargeting. And what I mean by that is, if you're grabbing like a moped like how do your hands actually grab correctly if you're changing body sizes. That's really difficult to do. And then the other key element is if you were going to create like 100 characters, 1,000 characters, 10,000 characters, or even the population of a city, who is going to validate it? Who's going to make sure that all those characters have been created successfully? And what I mean by that is that there are no artifacts on the final asset, like the body is not intersecting, for instance, the geometry of the jackets, okay? And last but not least, that output, how do we automatically ingest it in an engine? Okay, so as you can see, there's like really a lot of areas of research, and each one requires different expertise, and that's what we've been working on for the past pretty much 15 years and more. And what we've been working for the Presence project was just to encapsulate a great part of this technology so it could be actually used in the experiments by the other partners. So the big aha moment was the problem isn't actually creating one character, it's actually creating populations. And when I found that out, then we put all the resources in order to solve it. So nothing on the traditional pipeline could actually help scales to populations. Maybe I'm being a bit dramatic and saying nothing. We did use quite, some learnings from the traditional pipeline, but it means we have to rethink how that production pipeline looks like. And the main takeaway is that the way characters are created in a traditional way is very sequential. So someone designs the concept art, then it goes into someone that will create the 3D model. Then once the 3D model and the geometry is done, because someone will create the rig and the textures first, and then the rig, and then you go into animation. And the big issue is if something needs to change, the size of the number of polygons on the 3D model changes because the art director wants it to change because it will look better for animation. You got to go back all that sequential process. So, it's very tedious. So what we've done is a method that we're actually changing the concept from sequential traditional character creation to an agile method that at any point in time, you can change any component of that pipeline, and then the characters will be generated and the changes will be propagated immediately. So one of the research questions that I had into my career was actually how do we automate the entire character creation pipeline? That was the title of with a little bit of a twist, the title of my PhD thesis was how can I automate character creation? That was 20 years ago. And the news is that I literally failed miserably into how to automate character creation as a whole. I only managed to solve one tiny piece of the puzzle, which was automatic rig retargeting. And I created an algorithm that was one of the first ones that allowed to do that. And then it took all these other years to actually answer these questions. So this is a very important question that I've been looking through. So the behind the scenes is in order to create and scale characters, we had to rethink, and this is not the complete list, but very vast. So we had to rethink, okay, morphable models, how do we go beyond humans? Because as I said at the beginning, human likeness has been solved. So we then wanted to say, okay, what about beyond humans? So we had to think about how we can create topologies that are completely agnostic to different type of deformation models. How can we transfer styles without really creating any weird or hallucinated artifact? How we can create robust rig preserving fitting, and I will walk through each one of these issues later. So how can we, when we transfer assets, how can we have a rig that will not break? The QA and the validation at massive scale, which I mentioned before. How do we validate for artifacts? Animation retargeting, handling full body and face. That is still an open problem to solve. And in fact, all of this, you have room for optimization and improvement. And I'll happy take questions on that. And then last but not least, how we can, create data structures that are actually optimized to generate thousands and thousands of variations. So if I want to create the population of New York, how can I create a database and a data structure that can support the creation of that amount of people? So I will break this down into building blocks in 5 key insights. And I'll go a little bit fast because you'll have access to the presentation. So the first key insight is topology doesn't matter, right? So the huge breakthrough is how can we transfer data from one character to another character despite their topology. And this is experimental. What I'm showing you here is what it's a hybrid model. So we start with a human, and then we want to actually create, a creature or a fantastic figure, and how can we in real time create and paint modifications to change from a human to this creature. There's a lot of room of innovation in here. In this case, we're using morphable models. And this is something that the key thing that I would like for you to think is, how can I do this at runtime? So if you're getting into like a virtual scene or immersive application, how can we in real time go from a human to another creature, right? Key insight number 2, asset fitting. This is probably one of the most important components, because what we wanted to solve in this case, and as I mentioned at the beginning, the big innovation is that the art team defines the specifications. They define how they want the geometry, the textures, the rig to be, and then they create one character, and then all these characters are created automatically. So when they create that base character, they also create all the garments that goes on top of that template. Let's just call it the base template. So once they created, in this case, we have like a paramedic type of outfit, but it could be anything, right? So once they create all the garments that go on the base template, then we apply different methods in order to create variations of the body. And key elements that we had to research was, okay, how can we understand the rigidity of the garment? So if we look, I don't know if you can see very closely, but for example, the garment has like different gray lines. So how can we make sure that when the garment is deformed to the new type of body, certain areas remain the way they had to be? The same will apply to helmets and glasses and hairs, right? So understanding garment rigidity, how can we do detection of collisions between the garments and the body, so the body will not intersect and have artifacts coming out of the garment. So how can we do layering? So you can have garments that is a jacket, a t-shirt, and a belt. How can we make sure that all the components remain correctly set and they don't intersect between each other? So we actually created an algorithm that is intersection solver. So that intersection solver, after you created all the variations, you run this intersection solver, and it will detect if there are artifacts or the body gets intersects with the garments, and then we can apply and fix it. And I'll talk more about that in the QA section. So the key insight number 3 is variations as a controlled space. So once you model that space, you can generate thousands of high quality believable variations. So what we have here is a data set of about 220 human models. We created that database either by acquiring photogrammetry data or having artists creating those data sets. Based on that data set, we can apply, we use machine learning in order to create the variations of that space and be able to create different demographics across the world. So the data set represents the limits and the ethnicities across the world. So for humans, we have that cover. For non-humans, I'll tell you that in a little second. So once we nail down humans, we wanted to go one step above and beyond. And here is, okay, how can we do the same thing, but with stylized characters? So what you see here is just 6 stylized characters. These stylized characters have been created based on an input image created by the company we work with. And what they did is they generated with Midjourney different concept images. And based on the ones they generated, they actually generated 30. We created 30. We fine-tweak the algorithm we had for the humans, making sure that it will generate on the geometry space sharp edges around the face, exactly how it's looking into all the characters. So we created those 30 characters as our data set, and then we can generate unlimited variations. And the beauty is that all the new characters, they do not have a correspondence with the original image that the artists have been generated, but they will guarantee the art style. So once we have that algorithm, then we can fine tune it to do different art styles. And this is an example. So we had a template, and then we had, different variations on how that character would look like. And this is without applying the art style, and this one is applying the art style. So if I go back and forth, you can see one without the stylization and the other one with the stylization. And this is the result. Once it is ingested into the software, what is ingested into the software, you ingest the data sets for that art style. You import all the garments that you want to use and accessories, the animations, and then you can start mix matching how you want to do the characters. So this is another example that we did. The one in the left was actually developed. We automated the whole character creation pipeline for Kara, which is a game created by Electric Square from Keywords, and we presented it last year at GDC. So what they gave us was, instead of frontal 2D images, they gave us comic books images from the faces of the car racers. And we did exactly the same thing. And then we automated the pipeline, the automation of the character creation, and then those were then ingested as, for instance, holograms or the customization of your racer within your game. So insight number 4. So QA is really, really hard. And I believe it's very difficult to solve for all the problems yet. We're constantly implementing new algorithms. So we started with the intersection solver, but then you have the UV stretching. So if we look at these characters, the characters are all changing in sizes, but the detail of the textures remain intact. Then the other thing is, okay, how do you transfer the bone weights? So when you do the animations, it will look correctly. Another hard problem is, okay, we've done all the setup, we've done all the QA for characters with an LOD, let's say 1 or 2, but suddenly you want to have lower resolution, so you need an LOD 6, 7, and suddenly, how do you solve the intersections for those issues? Because what is happening is the number of triangles in the geometry is changing, the UV layout of the textures changes again, so it's very cumbersome how to solve for all these problems. And being animation, I would believe animation is still a very open problem to solve. So I'll leave you here with a lot of ideas on topics that you can research. These are some of the results we did for Colossal Order, for City Skyline. So we did all the characters for City Skyline. So automatically, so in this case, the team at City Skyline created the first base template of one character, and all these characters were done automatically. They are low resolution, so they have a very low LOD because of the type of game they have. Okay. So insight number 5, I think this one is very, very interesting, especially in the era that we are now with AI. So data is destiny. And what I mean by that is that there is not enough high quality 3D data to train models for characters that go beyond human. So for human, I think we have it pretty covered. But what if you want to create orcs? What if you want to create dragons? What if you want to create elves, anime styles? There is no data yet, right? So given the lack of data, and because data is kind of like the gasoline for a car, right? I like to use that analogy. You need gasoline, or in order to have your car running, you need, in this case, proper good quality data to create new 3D models. So we created this tool that is we call it a shape editor. So what you're doing is, again, the artist creates the very first base model with the rig. So the model will never break because it was already created with the adequate constraints. And then very quickly, you can start doing modifications, because maybe the art director say, okay, your data set is limited. I want a bigger nose, different ears, whatever. So you can come to the tool and really quickly create that modification. What that does is creates a new shape on the database. And then when you say create variations, then it will have been enlarged. So now you can start with a very small data set. So this leads that we could use this for things that are non-human. So what this unlocks pretty much is what the insights that I've given. It unlocks pretty much how we can create characters at scale in a really, really fast manner. And I'll walk you through now through some examples, because I think we still have some time. So the pipeline, very simplified, is you ingest, base character, all the accessories, your art style, the specs. That goes into our software. And then you automatically create all the variations, you fit all the assets, and then you apply the QA, the intersection solvers, to make sure that the characters have been created correctly. And then all that can be exported into an engine. So it can be imported into Unity, Unreal, or any proprietary engine. If it's Unity, Unreal, or proprietary engine, we kind of have like plugins that work already compatible. And because we have all the source code and the data sets, we can create different output output details. Let's say that, and we did this one for instance, City Skyline for Colossal Order. What they output was all the characters with the garments, but they didn't have the color on the textures. So colorization was done in the engine. So it's very interesting to understand how the different studios work, because then you can adapt your algorithms to the needs that they have. And I think that's the big differentiation between using a software out of the box. More than that, is just switching the mindset. Instead of, I want to build a software and have the users use the software as the software wants, is thinking how the user wants to develop the content, and then create a technology that allows the artist to maintain ownership. And that was the biggest challenge we had, and it took us many, many years to actually solve it. And there's still so much room for improvement. So I've already spoke about the stylize of the characters, so I'm going to skip that one. Based on the same concept, because we do have now the data set for humans, we can create synthetic characters that belongs to no one, right? And we did an article at SIGGRAPH that you can read about on how that works. And the key takeaway for you to remember in this slide is good data generates good variations, good fitting, and good motion. So if your input data it's really crappy, then you get crappy results, at least with the methods how we worked. So now building beyond, the humans, if we take the concept of what I explained on the shape editor, that you create one base character, and based on that base character, you can create new shapes. So we don't have a database of dragonborns, right? So it will take forever to create, let's imagine like a field full of dragonborns. So here in less than 2.5 minutes, you can start, like the artist can start, or the user can start doing modifications. I'm not going to run it all. I'm going to go through the video. But as you can see, every modification, what is happening is it's creating a new shape. So that new shape is stored as the new element of a data set. So once you're like really happy and you said, oh, I'm delighted, I've done all the modifications I wanted, then you can either define how you want the characters or randomly create all the variations of it. And so now what we have is a tool that allows to create a new data set for a new species or a new creature that has not existed. So that's that. I wish we could like automatically create all the data set, but we're not there yet. So we created this shortcut that solves that problem. So this is put in practice into like a really great game that is going to come out hopefully shortly, created by Playable Worlds. It's called Start Reach. So what you see on the left is the character editor and the shape editor inside Unity, developed for them. So we can customize the editor depending on the specifications and the needs of the studios. And then on the right side, you can see the characters coming out directly from their game engine. So the render, oh, this is important. So we don't take care of the render or the shading because that is very game dependent and engine dependent. So the tool on the left, you can see different colors on the outfits. Again, that's because they do the texturing that is on the right in the game. And they only use the UV layout that we've created as a reference to place the characters. So yeah, so that's a bit how it works. I'll move on. So this is a similar thing, but now inside the Unreal Engine. So we had to create an SDK for Unity and another one for the Unreal Engine. So in this case, what is on the left can be customized by the game studio, but pretty much very similar. So you create a character. In this case, we're making it compatible with MetaHuman because a lot of people is asking us, okay, how can we speed up MetaHuman creation? And so we created the SDK for fast creation of 3D characters. And I think, yeah, if I'll speed up this one, you can, maybe not, I think I'll have it somewhere else. You can see then the character embedded inside a 3D scene. So we have two pieces, one piece that works offline and it works locally in a computer. So it doesn't have to have, API calls to the cloud. So you can create all the characters locally. And then we have an SDK and plugins for the different engines. So at runtime, you can have a character editor. So creating a character editor for runtime also takes a lot of time. So that's what we've done. We created an in-game character editor for runtime. I think I've shown you that one already, so I'll skip it. And so these are the last few slides with the things that we're currently working on, because now we have very strong foundation of the technology. We said, okay, how can we quickly, in this case, create metahumans from either a photo, a prompt, or traits. So you can select a photo. Inside the plugin in Unreal, you create a 3D character and automatically created the compatible MetaHuman. We also do kind of like hair matching to be able to grab from the library from MetaHuman that character. In this case, is from prompting, and I'll show you how it works. We created a prompt that went into Nano Banana. Nano Banana in Google generated the 2D photo and then automatically created the MetaHuman. And then lastly, from traits. So we have all the traits here. And so you can select the traits or randomly generate traits, and it will, again, automatically create you the MetaHuman. So this is something that usually take quite some time and expert people within Unreal Engine experience just to create it. So now, of course, you need to know how to use Unreal Engine to make take the benefit of it, but it will just in no time create the 3D character. So really quickly you can set, unique characters very, very fast. So I started saying, photorealism and likeness is solved. I think it is personally, and we can expand it. Topics that are still open is optimization in all the everything that I walk through, everything that's got to do with optimization, they're open areas of research if you want to look into it. So this one now, same thing. We wrote a prompt, generated the photo, and then generates the metahuman automatically compatible with the animations. And these are animations out of the box taken from the Unreal Engine animations by default, just to show that it works well. Okay. And this is the example with the prompt that we use for generating the photos and then the 3D models. We've also experienced with Bing from Microsoft. I don't have a video here, but yeah, works seamlessly. So if you want to know how to do the full 3D photo to 3D, we have the papers available for that where we explain how we did it at SIGGRAPH. So you can take a look at it. And yeah, I'll show you just to finalize.
Infinite characters.
This is how it all came together with this game is already live. That's why I'm showing it. So that's the tool in action, and the generation of the hundreds of characters just with a click of a button. I think they did a total of almost 3,000 characters at City Skyline. But the beauty is that it could be agile. So if they didn't like something, they can delete it and create it again. So yeah, I hope you've enjoyed it and it sparked a lot of curiosity. I know I digested in 38 minutes a lot of information, but open to questions if you have any. So thank you.
Thank you, Veronica. It's fascinating to see how this thing evolves with the time. I don't know if you have any questions. If you have questions, don't hesitate asking them in the Q&A section or raising your hand. Meanwhile, I do have a couple questions. First is a more general questions because you work with several studios and you've mentioned here and there that you can use Gen AI or different from a prompt or to generate the images, etc. To what extent do you think that studios are integrating Gen AI or because what you're doing is it accelerates the pipeline, but the input that they gave you generally is artist created things or it's more generative content? I don't know if you can comment on the general impression you have.
Yeah, no, absolutely. There are different levels of studios. So you have like the indies, the AA and the AAA studios. So indie studios, they use whatever they have and they can. And this is my opinion, okay? So please take this,
Yes, yes.
as a personal thought. AAA studios, the ones that we work with, we go through like a very, very strong and intense security process. So no Gen AI in most of the big studios that we work with is allowed. So that's why it's very artist driven. The example that I gave that it started with a 2D concept art. Sometimes they use it like Mid-Journey just to create the initial concept art, but then we cannot use any Gen AI algorithms, tooling, or anything because they will not allow it. And that's it. So yeah, that's why we mentioned that we are like an automation layer, and the fact that we decided to own 100% of the source code. That was a big decision because it's very expensive to develop everything, and the data sets. Then that puts us on a safe place of people using our technology, but we're very often mixed and people doubt. So
Yeah.
it's a tricky one, very tricky one.
Yeah, it's tricky. Okay,
Yeah.
then I'm really curious because you showed several characters that are completely different
Yeah.
in facial, not only in appearance but also in proportions, etc. So when you reapply so can you talk a bit about applying animations between different characters? I mean, I'm imagining for video games it's something that can be done offline, but for VR, for example, facial expressions, it would be interesting to explore in real time. So can you comment a bit on both?
Was it this one that you were talking about?
I don't know. I've seen
Ah,
characters that are very, very different in
very
your
different.
talk.
Yeah.
So,
So just a small clarification. On this one, they had 6 different species. So we had to create, the artist created, so this is one species, right? They created one base template for each species, and therefore we can do the variations, and then they use the shape editor to create the initial variations to create the data set, and then based on that we applied the modifications and we create all the characters. So if they're completely like from a dragonborn to a human, you need 2 different templates.
yeah, that's for
Yeah.
the character creation. And then for the animations, when they apply the animations to different characters, they need to
Oh,
rework
we can
them.
no, we can do retargeting between different styles and different, like we can do retargeting from this, this one here from the previous one. Animation retargeting from to that one, animation retargeting, asset fitting, that can be done as long as they share the same topology. We can do the retargeting.
Okay.
If they don't share the same topology, we do have a method that does a wrapping. You retarget, and then you kind of like do the wrapping again to the final geometry. So at this point, we can work with different type of geometries, meshes. Yeah.
Okay. Interesting. So Karen from PCM Creative asks, uh, basically, you've said that you don't use AI. So how do platforms such as Nano Banana fit into this non-AI ecosystem? It's a bit what I asked, but maybe you
Yeah.
can explain a bit more.
Yeah. That's a great question. So we don't like Nano Banana for us is not part of our platform. It's an input. Is to generate the input into the software. So we never want to have ownership over the how the input gets into the software. So either the art style or the selfie, how they generate it, the mesh, how the quality is. We don't own that. So however the user want to generate that input data, they can do whatever they want. Then what we encapsulate is from the input to the output, the FBX file that generates. And then once we give them the FBX file or any other format, then that belongs back to the user and they can do changes or anything. So in the core of our engine, we use machine learning, computer vision algorithms, computer graphics, but we don't yet use any LLMs, if that's the question. Hopefully I made it
Yeah,
clear.
yeah. That I think it was very clear. There's someone asking, Halidonto is asking if it integrates with something that I don't know, so I hope I pronounced it correctly. Confue. Do you know this platform or system?
Confuse, no,
I don't know what that is. So
no.
it's something to generate videos and 3D. So I think the answer
Ah,
is the same. You can generate the images with that
right.
and then use your pipeline to generate the character, correct?
Yeah, correct. Yeah, so input can be a photo or a 3D model based template, and the output will be an FBX or another compatible, 3D file format. Yeah.
I have another question about movement animations. For example, a typical problem you get when you transfer movement, or I mean, when you do motion capture and you grasp an object, is that if you are like me and you transfer it to
Mm.
a tiny person,
Mm.
then the contacts don't work anymore because obviously the arm is not the same
Yeah.
length, etc. Is this something, because with all the variations that you're creating, I'm wondering, do then studios need to rework the animations and rework them for the different variations that you've created, or how do they do it?
That's a great question. So for a clear one, and I shouldn't be using weapons as an example in this webinar, but it's the only one that comes to my mind. So if you have like a big
Big
gun or
gun.
big sword, yeah, exactly, and then you have a small one, and you have a big King Kong size character, and then you have little people, then definitely it's not gonna work. So usually the games, they already know who's gonna use which character, so it's part of the gameplay. So it's part of the setup, so they have to make sure that whatever assets they create, they already fit correctly into the base template. Yeah.
Okay. I think we need to finish a bit early because Veronica needs to run to another meeting because she's always in many different things. Maybe we have times for one more question. If
Yeah.
someone has one more, I don't see any here. So maybe I will ask a more general question. So what's next? What do you think is next for Didimo? Because now I think generating characters is done. You've been working with several companies. This thing is going. How do you see the future here?
Oh, so the dream is, we can have as many studios kind of like using the software to generate their games. So I think the big challenge is how do studios that are starting to integrate automation, they embrace this technology. So there's a big transformation process going on in the industry, and and we're part of that transformation. So yeah, that's one. And then the other one is I have this dream or vision is how can we bring artists to create different base templates of elves, orcs, so we can create like a database of templates. So then we can create different methods like using populate so to generate all that data set, and then the artist would benefit. Now, if they want to sell it, they can, they will do it faster, right? If they want to, instead of having to spend 10 days creating 10 different characters, they only need to create one, and then they can just create packages for asset stores and so on. So it's how can we empower artists to create content that is repetitive work faster. So I think that would be amazing. So yeah.
And I think that on this aspirational note, we will finish this seminar. Thanks all of you for attending. And if you have questions, I'm sure you can join the people in the consortium by mail or with other means. The recording of this and the slides will be available in the near future.
Excellent. Hey, Mel. So good to see you.
Great, thanks.
Yeah. Thank you. Bye.
Bye.
Bye-bye.
Bye.
Bye.
Gràcies, Joan.
Gràcies a tu. Ha anat
Que
bé, no?
vagi
Més o
molt bé.
menys?
Sí, no, molt bé, molt bé.
Perfecte. Adéu, bona
Gràcies.
tarda.
Adeu.
Adéu.
Vagi bé.